Hello everyone, welcome to my channel. Lately I plan to work on some audio project. I was looking for some chip has Bluetooth capability and has also able to connect the microphone and speaker and also provide very low power consumption. So I look into several candidates in the market, so including the ESP32 and ESP8266 and also the STM32 as well. But then finally I end up with this NRF 52 series, which is from Nordic Semiconductor. And they are very specialized Bluetooth chip and especially low power capability. So this is very good. So that means I can use the battery to power the device I have made. You can see I'm actually getting this development board. This one is contains a 52A32 chip. This one has a 64 megahertz ARM M4 CPU, and it has also some DSP instruction sets, which means we can use it to process audio, run some DSP algorithms, for example the FFT. And the ARM also come with a library to work on that, so that's very handy. And because I'm always like to find the good stuff on the web, so when I'm searching for this development board, I was looking into AliExpress and I just put in this NRF 5232, and then I end up with this page. Actually, I can do a search. So yeah. Now you can see here we have some modules available, which is cheap, very cheap as well. But this one I need to solder the interface myself and also the power. So I was thinking maybe it's easier to just go for this kind of board. I didn't see this kind of board before, but I do buy one. Actually, I bought one which is like €5 something, about €5. So this is what I got. As you can see, it comes with three LED. No, one is power, so the other two is LED we can use, and it also comes with two push button. The push button, one is the reset, and the other one is the mode. Basically, we can customize this button. And then it also comes with the USB to UART conversion. So basically means we can connect to the USB port from our computer and then load the application into the chip. So this is very handy. And this development board comes with built-in firmware in the beginning, and it was locked. And also it has the firmware that connected to Bluetooth, and we are able to send some AT command to it to send data and do some operations. But this is not satisfying my requirement. I want to develop my own software and load it into that. Therefore, I used the Adafruit. I burned my bootloader into the device so that I can use later this USB port to load the firmware that I write into this one. In this video, I have already write the Adafruit bootloader, which is this one. I can here 52. So basically, this is the open source project Adafruit bootloader. So it supports actually a lot of boards. It also supports this eBay board. So we can just go to release here, and then you can see there are eByte board supported, which is very handy. So basically I just download this one and I use the ST-Link to load into the like this one, to load into the firmware here. I will make another video to show how to load the bootloader into this eByte board and then upload the firmware by the USB. Okay, so now since I already have the bootloader inside. So it has two modes. One is the OTA mode, which means we can update the firmware from directly the Bluetooth connection. So it means you can connect to your phone and then you do the firmware upgrade. Apart from that, there is also USB serial mode. To enter the OTA mode, it's quite simple. When you have a bootloader inside, so you can press the mode key here, and then press the reset, and then release the mode key. In that way, you can see the second LED is going up and down slowly. So that means it's already entered the OTA mode, and so that you can then go to your mobile phone and start loading the applications. But for my purpose, I just want to load from the USB, so I can just press the reset button, then it will just have a short amount of time that is waiting for the firmware. So now I'm gonna try to build my own application, and then I will load the application into the development board. So let me just first put it to OTA mode, just so that we can see that the light is different. So okay, now it's entering the OTA mode. So I'm using the Sega Embedded Studio. So here I have the Blinky example open. So the Blinky example is basically made for the board from NRF. They have the PCA 10040 boards that is about 50 euros, and they come with a lot of capabilities, but in this case I'm always looking for a very cheap and easy solution for starting. You can see the Blinky example is here. Let's look at the main. So you can see it's very simple application. The board unit is here, and then it has the LED invert. So it's trying to go through all the LEDs in the board on the board, and then invert each of them, and then delay 500 milliseconds. So what we can do is actually we can build it. Usually you shouldn't have any problem building the application by just opening the example folder. But now for this one, because it's made for the other development board, so we need to adapt to this development board. So in here we have two LEDs, so if you flip over you can see the pin definition. The data is actually connecting to pin 31. So data is here connecting to pin 31, and then the link is another LED is connected to pin 30. So when we know about this, we just need to go to the place. Okay, so this is the board definition. So we have here LED numbers. For the PCA 1040, there are 4 LEDs, but for this board we have 2. So we just need to adapt the LED number to 2, and then specify the LED star, LED 1, 2, and remove the LED 3, 4, what they have. So it's like this. And with that, we should be able to burn the application, and then make sure you modify, adapt to those the pin numbers. After adapting that, you should be able to build the application and then start running. So let's do that. I'm just do the review because I'm pretty sure it's working. So, and then we can go to the output folder. We can look at it. So we have generated 3 files. So one is the L file, that's different format than hex, and then we have a map file. So what we are going to use is the hex file. So in order to use this hex file to load into the development board, we can do this. So we can first convert the hex file into the zip file, this is the Adafruit util, which is converting the hex file into the DFU package. So you can see here we have DFU, we have generate package command, and then the device type is specifying the 52. So this is our device type, and then we have a SD requirement. So this is a B7, which is a 6.1.132. We have a different soft device available, but then this soft device is actually come with the bootloader, so you can find it in the Adafruit release notes. So, and then the application, this is the hex file we are just building, and then we need to put it to a zip file. So basically we should say Blinky, like this one, Blinky PC A1040. Okay, so you can see the conversion is done, and the second step is we need to boot it, like burn it through the bootloader. So now you can see the LED is now blinking. It's in the OTA mode, so we need to press the reset button here, and then press the burn. So when we press the reset button, it will enter the DFU mode for serial connection for a short time. So when we press this one and then we press the other one, so you can see the application has been burned and the new software has been loaded into the device, and then we can see the LED star lighting up. So yeah, this is a very simple video to show how to get the LED example running on the eByte development board. And this is a very cheap and easy solution. Yeah, I hope this video will help you. So I will make some more videos about the audio project later. I hope you enjoy the video. See you next time.